If you add up every single search query, text message, and email you draft over your lifetime, you will spend roughly 5 whole years of your life just staring at screens and typing. But because of Autocomplete, you will save nearly 1 full year of pure typing time over the course of your life. That is an extra 365 days given back to you just because a computer is guessing what you want to say next. Right now, that invisible mind reader is sitting inside your phone, your browser, and your email. It guesses your thoughts, finishes your sentences, and alters how you communicate. Today, it feels like basic digital plumbing. But the journey to get here? It didn't start with smartphones. It started with telegraph operators in the 1800s, exploded because of a massive crisis in Chinese computing, and was supercharged by a rogue Google engineer working a side project. From ancient shorthand to modern AI, this is the secret history of how our machines learned to finish our thoughts. Humans have always hated wasting time typing out full words. In the late 1800s, telegraph operators used standard abbreviations to save precious bandwidth, while Greg's shorthand allowed people to write at the speed of speech. It did this by throwing out the alphabet entirely and replacing letters with simple, fluid strokes that represented phonetic sounds rather than words, essentially letting a writer compress a whole sentence into a few rapid flicks of the wrist. But things got wild when digital computers arrived. Imagine trying to type on a standard Western keyboard when your language has tens of thousands of unique characters. This was the massive crisis facing Chinese computing. In 1959, an MIT researcher named Samuel Caldwell built the MIT Sinotype to solve this problem exclusively for Chinese text. The Sinotype didn't require a key for every word. Instead, it relied on a brilliant realization. Every Chinese character is made up of a specific sequence of basic foundational brushstrokes. To type a word, the user just pressed keys corresponding to the first few strokes. The machine would look at those initial strokes and automatically predict and display the correct matching character clusters on a screen. To make this kind of lookup instant, computer scientists pioneered a data structure called a trie, which is short for retrieval tree. Instead of a computer searching through a massive, flat list of 1,000,000 words every time you press a key, a trie organizes data like a digital roadmap. Think of it like a spelling tree. The root is empty. The first branches represent the first letter of a word. The next branches represent the second letter, and so on. When you type the letters C-A-T, the computer doesn't scan a whole dictionary. It simply follows the C branch, moves down to the A branch, and instantly stops at the T node, revealing every word that starts with cat down the remaining path. It turned a massive search problem into a quick single-path walk. By the 1980s, Autocomplete went digital in the West, originally as assistive technology to help people with physical disabilities reduce the physical strain of typing. But up until this point, Autocomplete was entirely self-contained. It only knew the words hard-coded into its tiny local dictionary or the files you had already typed out on your own machine. It could help you finish a word, but it had no idea what the rest of the world was thinking. But that was all about to change. The modern era of autocomplete that we actually use right now truly began in 2004. Before this, web browsers could only complete a web address you had already visited. They couldn't predict new information. Enter a Google engineer named Kevin Gibbs. Gibbs was utilizing Google's famous 20% time, a policy where engineers could work on passion projects. He noticed something annoying. People wasted countless seconds mistyping search terms, waiting for the page to load, realizing they messed up, and starting over. His solution? Google Suggest. But this was a monumental technical hurdle. To make Google Suggest work, the system had to analyze billions of searches happening around the world in real time. Even tougher, it had to deliver those recommendations to your browser while you were typing without refreshing the entire web page. To pull this off, Google utilized a web tech known as AJAX, asynchronous JavaScript and XML. Instead of hitting enter and waiting for a whole new web page to load, AJAX allowed the search bar to quietly ping Google's massive servers in the background with every single keystroke. By 2008, Google made this the default worldwide. By 2010, they launched Google Instant, dynamically updating the entire search results page with every letter you pressed. It changed the internet from a destination where you go to look things up into an engine that interacts with you mid-thought. Up until around 2014, Autocomplete was essentially just playing a numbers game. It was built entirely on global popularity and strict rule-based dictionaries. If you typed the letter B, the system would look at what everyone else on Earth was searching or typing and guess banana or weather. It worked fine for general terms, but it was completely blind to you as an individual. It didn't understand the nuance of your specific voice, who you were talking to, or what you were actually doing in that exact moment. To break past that wall, the technology had to shift from simple statistics to machine learning and neural networks. In 2014, Apple launched QuickType to bring this new era to mobile devices. Instead of just pulling words out of a generic static list, the technology was improved to factor in real-time linguistic context. If a friend texted you, "Do you want to grab dinner or a movie?" the keyboard's algorithm would scan the incoming sentence structure and instantly offer dinner or a movie as one-tap buttons. It was looking at the relationship between words rather than just checking a dictionary. And in 2018, Google introduced Smart Compose for Gmail. Instead of following a rigid word-by-word rulebook, it utilized recurrent neural networks, RNNs. As you typed an email, the AI would process the entire sequence of text you had already written, calculate the mathematical probability of your natural train of thought, and automatically draft whole phrases or sentences ahead of you. You didn't have to type out long corporate pleasantries anymore. The AI just handled them for you. And today, we've moved far beyond finishing simple sentences in an email. Modern large language models like ChatGPT, Claude, and Google's Gemini are essentially autocomplete, scaled up to an absolute macro level. When you type a prompt into these tools, they aren't thinking or feeling the way a human brain does. Under the hood, they are running highly advanced versions of that 1959 prefix tree logic, calculating billions of probabilistic paths across trillions of parameters to guess the next token, the next word, and the next paragraph. They are finishing your entire thoughts, essays, and computer code based on everything humanity has ever written. What started as telegraph shorthand to save money on copper wires evolved into an engine that guides how humanity communicates. When we accept a suggestion, we participate in a massive loop where humans train the machine and the machine subtly influences the human. Next time your phone finishes your sentence, remember, you're not just looking at a convenient little feature. You're looking at over a century of human ingenuity squeezed into the palm of your hand. But think about the sheer scale of this for a second. For autocomplete to guess your next thought in milliseconds, companies like Google have to process billions of search keystrokes every single second. It requires an absolutely massive, invisible infrastructure operating in the background just to handle that continuous flood of global information. If you want to see exactly how Google manages this mind-boggling amount of data without breaking a sweat, you need to watch our deep dive into Google's hidden data infrastructure right here. Click on the video on your screen to find out, and I'll see you there.